Today we're starting our last little topic on statistics. Now we have less than 2 weeks to do statistics. In fact, we have today, Monday, and next Wednesday basically to do statistics. So we're not going to get nearly as deep in this topic as I would like to. Personally, I am a firm believer that everybody that graduates from college should have a statistics course. Not necessarily from a 2-year degree, but by the time you get through a 4-year college degree, you really should have a statistics course, because statistics is really the way decisions are made. You get into business, the people that end up getting promoted into the upper level management and vice president positions have a statistics background. In fact, you look at the major corporations, their CEOs and vice presidents, 90% of them have 2 qualifications. 1, they have an accounting background, and 2, they have a statistics background. So it is huge. It is how you interpret information, not just numerical, but just information in general, and use that information to make decisions. Now, we're not going to have time to get deep enough into it to get into that whole decision-making process. And to get deep in, you have to understand probability in order to understand how statistics are used to make decisions. We'll talk about that maybe a little bit over the next few days. Hopefully we'll get to have time to talk about it a little bit. We won't have time to actually sit down and go through the process and see how it works. But anyway, the first step in dealing with statistics is gathering information. Now, once that information is gathered, the statistics are used for 2 things. Now, some people view them as 2 separate branches, but really they're not. They're 2 steps in the same process. The first step is something called descriptive statistics. Descriptive statistics are gathering that information and then using it to describe something. For example, let's say that I gathered information on students at WITC. And I was able to come out and say, hey, the average age of a student at WITC is 32 years of age. Or the average time it takes to complete an associate degree for students at WITC is 5 semesters or whatever. I can describe the population, or I can describe general characteristics of that population, of that group. The second type of statistics, or in many cases the second step beyond descriptive statistics, is something called inferential statistics. And I mentioned they're steps of each other. I call them steps of each other because in order to really use inferential statistics, you must have some sort of a description of what you're doing. Now, they're not necessarily using the same information. Sometimes what they're doing is they're taking the descriptive information and using it for making the inferential statistics is now taking the information, using it to make a decision of some sort, to get some conclusion about things. Sometimes you're taking that same information and putting it into the process. Other times, the descriptive statistics kind of set a benchmark for you to base your initial assumptions off of, but then you have to gather completely different information on it. For example, inferential statistics would be saying, gathering information about the students at WITC and then saying, hey, I should market to working parents, because that seems to be the fastest growing group of students at WITC is working parents that need flexible scheduling. So that's who we're going to market to, and that's who we're going to schedule around, is that group of people. That's taking that information and making some sort of decision on it. Now, what we did there didn't necessarily go through any sort of formal statistics process. We just gathered the information and looked at it and said, hey, it looks like this group is growing fast, and this is going to be the group that we could have the potential to gain the most from. And that's fine. That is inferential statistics, looking at the information and making a decision. But there are also formal processes called hypothesis testing and confidence intervals and stuff like that allow us to go through a little bit more of an organized method of making those decisions as well. So anyway, let's look at gathering information. To gather information, we must define a little bit of vocabulary. You heard me throw this word out a little bit ago. Population. A population is the group you want to learn about. Now we're talking about students in WITC, average age of students or average time to complete a degree, whatever. The population there is WITC students. Now, more specifically, when I said how long it takes to complete a 2-year degree or associate degree, I'd have to be careful because my population is not all WITC students at that point because some of our degrees are only 1 year. In that case, our population was all WITC students enrolled in 2-year degrees. So you have to be very specific. A common statistical study, of course, is dealing with politics and elections. Who are you going to vote for in the next election? Or trying to predict who's going to win the next presidential election. In that case, can anybody tell me what the population would be? What's that? Is my population the presidential candidates? I want to learn which one of them will win. Isn't that what I want to learn about? Say no. What am I really trying to learn about here? I'm not really trying to learn about the candidates themselves. I'm trying to learn about the people that are going to elect them. The candidates don't determine the election, the people who are voting. So what I want to learn about is, and this one can be defined a couple different ways. You could say I want to learn about all voters in the United States, but more specifically, I want to learn about all people who will vote in the next election. I don't care if they're a registered voter and they don't vote. If they're a registered voter and they don't vote, I don't want them to be part of this group because they're not going to determine the next president. Or there are some people who are not legal voters who still manage to vote. I want them included even though they're not a registered voter. I want them included because they're going to determine this outcome. So the population in some cases can be kind of hard to define. You have yes.
Will their vote matter if they're not registered to vote legally? They can't vote. So
but some people still do. Every election, there's people that legally are not allowed to vote that still vote and they get counted. If their vote's going to get counted, I want to know about it because that's what I'm trying to learn about. Is what the result of the election is, whether it's legal or illegal or otherwise.
They're counted.
And technically, the people that vote twice, because it happens every election, there's people that vote 2, 3, 4 times. To me, they're 4 separate people. If they vote 4 separate times, that's 4 separate people. One way to look about it is actually it's not even the voters I want to learn about. It's actually the votes themselves that I want to learn about. Yeah. But at this point, the votes don't exist. The votes don't exist until they've been cast. So I have to look at the source of those votes, which are the people who are going to vote. Now, this actually leads to the next vocabulary term quite well, especially with this example, a sample. A sample is a smaller group drawn from the population. Why would we take a smaller group? Why would we not just look at everything in the population and make sure we have it right? Well, there's several reasons for drawing a sample. One, time. Time is a factor in a lot of different ways. One is my time. If I want to learn about the results of the next election, how many registered voters, how many voters are there in the United States? Well, every election there's like 130 or 120 to 130 million people who vote. Do I have time to pick up the phone, find the phone numbers, and call 120 million people? No. Probably not. First of all, many of them aren't going to answer. Many of them probably don't have phones or whatever. So there's other things that would keep me from even being able to get to them. But the time, if you think about it, even if it took 15 seconds. If you could call 4 people a minute and just say, hey, who are you going to vote for? This person, okay, bye. Next person. 4 people a minute even, which would be 240 people an hour. What's that? Well, in some, sort of. At 240 people an hour, which is a ridiculous pace, it would still take 500,000 hours. Now divide that by 24 hours in a day, it would take 20,000 days. There are 365 days in a year. Oops, divided, not times. It would take me 57 years to survey every voter in the United States. I don't have that. I mean, okay, so I could get a crew of, maybe I get a dozen people working on it and we can get it done in 5 years. 2 things happen there. One, it's a lot of time. And of course, that also brings us to the second thing here. Money. I don't really want to pay people to make those phone calls. But the time itself, the fact that we don't have that kind of time. But 2, time comes in as a second factor, because if it's going to take 5 years to survey all those voters, in the course of 5 years, what happens every 4 years? There's a presidential election. So guess what? The thing I'm trying to learn about has already occurred. Second, let's say, even if it took just 1 year to survey all the voters, or even 6 months, how many of you have, 5 months before an election been absolutely certain you're going to vote for a person, and had something happen and you changed your mind and you voted for somebody else by the time the election got there? Maybe it hasn't happened to you, but you can see there's a possibility, right? So if it takes you 6 months even to get through gather all the information, by the time you've talked to the last voter, the first voter may have changed their mind. So you have to get this done in a reasonable amount of time so that the conditions stay the same. Think about if you're surveying somebody on their viewpoints on gas prices. So let's say you want to survey a bunch of people. Well, if it takes you too long to survey the people you've selected, and let's say gas prices go up by 30 cents a gallon over that time. Well, by the time you get done, those people may be way more unhappy with gas prices than when you started, because prices have changed. So you have to make sure you get the information gathered quickly enough so that everybody is being surveyed under the same conditions. Does that make sense? So money is in there. I'm just going to put down logistics. Logistics is kind of what I said before, especially if you're doing surveys. Some people just can't be accessed. When they do the census, they talk about that census every 10 years. They claim that they are going to, it's not a survey, it's a census. There's a difference between a census and a survey. A survey, you just select a few people of the population. A census, the definition of a census is you try to gather information from everybody in the population. A survey goes out to a sample, a census goes out to the whole population. But anyway, the census, they're trying to gather information from everybody. They can't. I mean, they spend 4 or 5 years trying to gather information. In fact, just last year, they were still hiring people to go out and try to gather information from people who had not yet responded to the 2010 census.
I've never responded.
They've never sent anybody out to your house? Because in a lot of cases, they actually will do that. If you don't respond to the one in the mail, they will send someone to your house trying to gather the information. Technically, it's a crime not to respond to the census. I'm serious. I'm not turning you in or anything, but... Huh.
I guess you don't turn everybody in.
No, I'm not going to turn anybody in for it. It's just, I think it's kind of funny. There actually is a lot of stuff that's determined. Like the voter districts and stuff like that are actually redistricted based on the census.
Somebody has came to my door, but it's a small town and I'm the person. So,
Sure.
It didn't matter.
Yeah.
She asks me questions, I answer it.
Oh, yeah. Well, and a lot of times, they go out and they realize that the person who didn't mail back in the census, they can't read, so they had to have someone. So, how are you going to respond to a mail census if you can't read? But I mean, I feel bad. I mean, I've had friends that have done that job before. They pick it up, they'll hire you for like 4 or 5 months over a summer to go do that. And a couple of them said they've been in some pretty scary places where they didn't know if they were going to make it back out. Because some people were not real happy about having someone show up at their door.
Even it would still not be possible because
Yeah.
for a lot of people you call, they're going to hang up on you and not answer.
Yeah.
So it's none of your business.
Or if it's a
and it wouldn't be possible to have an accurate, in the end. So it's still against the law.
yeah, and that's that whole logistics thing where it's just you just can't possibly people don't respond or they won't talk to you or whatever. There's just no way.
Just the opposite because they can.
Yeah. Oh yeah. Now the fourth one, this is getting away from like the surveys and phone surveys and stuff like that. A lot of people don't think of statistics being done this way, but I throw it in there just to kind of jog people's mind a little bit and change their focus a bit. Statistics is used a lot in manufacturing. I've used a lot of statistics in quality control. For example, let's say that we're a manufacturer is producing a part, and that part is going into a car, and in the car it has to be able to handle a certain amount of force. Well, how do we make sure that that part can handle that force? Well, we grab one of the parts off the line, we take it over to a tester, we put it in a tester that can apply that amount of force to it, and we see if it breaks. In fact, not only do we apply the amount of force it needs, we actually keep applying force more and more until it does break. And we measure, hey, it actually held twice as much force as what it has to. We know that's good. Because if it broke just above, let's say it was supposed to hold, 800 pounds, and let's say it broke at 805 pounds, would that make you feel real safe?
No.
Not really, no. But if it breaks at 1,500 pounds, you're saying, hey, it held the 800 plus more. So I'm pretty sure that the other parts over there can hold it too. Can I test every part coming off the line?
No.
Why not?
These, let's see. You test every single part that comes off the line. You're not only using money, you're also using time, and a few of them might break.
Well, yeah, not only is it taking too much time and it's costing me some money, but according to the way I define this test where you actually apply force until it does break, well, I'd be breaking all the parts. They'd all be destroyed and there wouldn't be anything left to sell. So you have to take a sample. Maybe you choose every 50th part or every 100th part to go through and you test it to make sure, hey, it's still holding twice as much force as what it needs to. We're pretty sure that the other parts are good. What happens if you have one that you take it and it breaks at 805 pounds? You immediately go out there and grab another one and test it, right? And if that one breaks at 805 or 810 pounds, you're shutting down the line and you're going back and you're gathering up all the parts and you're figuring out where it was that things went wrong.
That happens a lot with vehicles, right?
Yes, it does.
My son just had an accident last week where he had a brand new Lincoln MKZ and the steering wheel locked up on him, and he was going 55 and it locked.
Yep.
And he knew he was going to crash, so he slammed on the brakes. So he ended up smashing at 30 miles per hour. But nothing's going to be done about that because they have to have so many for that.
It's the local business.
Yeah.
You have to please the people.
So, I mean, there's a lot of reasons why we take a sample instead of testing the whole population. Now, there's a couple of words we threw out there. So I'm going to put this out here. Just list this population and sample. There are some related terms that go with it. We mentioned the word survey. A survey is a device for gathering information about a sample. You're asking questions of generally people. For population, the word would be census. And as we said, you can never truly do a census because some people just will refuse to respond. The word statistics, or statistic. A statistic is a fact describing a sample. So let's say I want to learn the average age of WITC students. Well, we have a couple thousand WITC students. Let's say I survey 200 people. And I say, okay, the average age of the mean age of the 200 people I surveyed was 32.4 years of age. That's a statistic because it's describing the sample. Now let's say I turn around and say, based on that, we're going to say that the average age of a student at WITC is over 30. That's now describing the whole population. That's what we call a parameter. So that parameter is a fact or a piece of information that's being used to describe the whole population. Generally, statistics, describing the sample, we can calculate those out exactly. We've gathered the information, we've calculated it's exact. The parameter, a lot of times, because we can't actually gather the information from every piece of the population, a parameter is a lot of times a conclusion drawn from a statistic and then just modified. Like that example where the actual mean, the actual average of the students we surveyed was 32.4 years. And then we used that to make the conclusion, hey, in our whole population, the average age is over 30. That became a parameter because now we're using that to describe the population, even though it's not an exact figure. Surveys are very, very important. Samples, I should say, are very important. By the way, another way of gathering information from a sample is to set up what we call an experiment. In a survey, you're just sending out questions or asking questions to get information on what currently is happening. In an experiment, you are actually creating certain conditions and then observing what happens, observing what's going on. A great example of experiment is drug testing, by the way. You're taking a patient that has a certain condition, you're giving them a treatment, and you're seeing how they react to it. So that's an experiment. You've set up those conditions. Of course, there's other ways of doing experiment, like we talked about the testing for the manufacturing. That's an experiment because you're taking a part and you're applying some sort of conditions to it. You're creating those conditions to see how it reacts. So anyway, the sample is very, very important. In fact, how we choose the sample is extremely important. A sample must be what we call a representative sample. A representative sample very simply mirrors the population. If 30% of the people in the population are in favor of a certain candidate, well, then it better be really close to 30% of the people in our sample favor that certain candidate. Otherwise, it's not a representative sample. We want to avoid sampling bias. Sampling bias is a difference between the sample and the population. What's that? No, a bias, the term bias actually means a tendency towards one side or another. To be unbiased means to be completely, have no preconceived notions or no prior tendencies. There is a bias in the nature. I know what you're talking about. It's not the word bias. It's similar to the word bias, but I know what you're talking about there. I think it's slightly different. I'm not sure, but it's okay. But anyway, so let's say looking at all those parts that I was manufacturing, and let's say all of them are good. But I just happened to choose a part that was bad when I tested it, and it broke it less than what it was supposed to. Well, that was a sampling bias. I just happened to choose one of the bad ones. The parts are actually mostly good, but I just happened to get a bad one. That's a bias. Or let's say I take 5 of those parts and all of them are bad. Well, I just chose a bad sample. The parts themselves weren't all bad. It's just I had a bad sample. But we don't know that for sure or not, do we? Once we take the sample and test it, we don't know whether it was a good sample or not. So when that sample comes back that those parts are weak, we still have to shut down the line and go back and test and make sure. So the question is, how do we avoid sampling bias? How do we come as close as we can to getting a representative sample? There are 2 things that come in. Number 1 is sample size. We are not going to get into the whole sample size argument a lot because there are so many different rules and possibilities about sample size. There are all sorts of them out there, like if you know how many people are in or how many items are in the whole population, there's formulas to, the square root of the population size and blah, blah, blah. There are things if you're dealing with percentages, the percentage times the size of the population should be greater than 30, little rules of thumb like that. But there are so many different rules, and depending on the situation, there's so many different things you should have to undergo that determine what an adequate sample size is. But in general, when it comes to sample size, a bigger sample is usually closer to the population. Think about it. If I want to know what percentage of the population is going to vote for candidate A, and I survey 2 people, and one says yes and the other says no, I just said, hey, 50% of my sample is going to vote for candidate A. Is that a very representative sample? No. In fact, I might have had both of them say yes, and I could have said 100% of my sample. But in reality, there's a good chance that it might be less than 100% that's going to vote for that candidate, or even different than 50%. So that obviously two people or 2 items was not a large enough sample. The second thing is the selection of the sample. Let's say I determine that I only need to survey 20 students. And that's a big enough sample to determine the average age of students at WITC. So once I've decided, hey, I only need 20 students, I run out in the hallway here and I ask the first 20 students I see how old they are. Is that a good sample? No, it's not. I'm first of all, I'm at the trade and technical end of the building. I have the Woods program right across the hall from me. The Woods program tends to have younger students because of the major physical labor. Automotive program down the hall, again, tends to have younger students. So just this end of the building compared to the other end of the building, the business end, where the average age tends to be slightly older. Also, the time of day. We're sitting here at 9:15 in the morning. Sometimes there's certain students select, different age groups will select classes at different times of the day because it fits their style. There's all sorts of things that come into it. What I just mentioned there, just running out the door and taking the first 20 students that I see, that is what would be called a convenience sample. You don't need to write this down. You won't ever be tested on it. A convenience sample is generally a bad form of sampling. I'm just doing it because it's easy and convenient. And unfortunately, this is one in most of your published surveys and political surveys and stuff, a convenience sample is generally how they are done. Now, a second really bad form of sampling. I could go down to the new lounge down here, the hub or whatever they call it, and I could set out pieces of paper on the tables and say, hey, fill this out and put your age on it so I can use it to figure out the average age. That's what we call a self-selecting sample. Now again, because you have the ability to just walk away from it and not do it or fill it out and turn it in, it's not very controlled. And there might be a certain age group that's more likely to fill that out and turn it in than others. Like a lot of your 18 and 19-year-olds might look at that and say, I don't want to deal with that. Or they may look at that and say, hey, let's mess around with it. And they might put down 92 as their age or something like that. And of course, you always have that result, that possibility of improper or incorrect or results, information being given. But self-selecting samples where the person determines whether they're in the sample or not. The biggest place this gets used is, again, on surveys. They'll mail out a survey to your home. And is there anything forcing you to fill it out and send it back in? No, you get to determine it. This happens in politics and other things all the time. If I am trying to claim that we need more laws protecting animals, I'm going to send out a survey, and on the envelope, I'm going to put, SPCA or something like that, or Animal Protection Group or something on that envelope. Well, guess what? If you're a person who's very passionate about protecting animals and you see a letter from that group, probably a pretty good chance you're going to open it. And if you read the little thing that says, hey, this survey is helping us do things to protect animals, there's a pretty good chance you might actually fill it out and send it in. But if you don't give a crap about animals and protecting them, and you see that, there's a good chance you're not even going to open the envelope, you're just going to throw it away. And even if you do open it and you read that, I'm not taking the time, I don't care if we protect it or not, I'm going to take the time to fill that out and send it back. So, I mean, just that alone, the only people that have strong opinions or strong emotions about it are the ones that are going to take the time and fill it out and send it back in. So it's a self-selecting sample. I actually did a study on this in college, one of my research papers for one of my classes. I got permission from the Republican Party and the Democratic Party of Wisconsin to use their envelopes. I sent out 1,000 surveys. Identical surveys, except they had a little symbol up in the corner so I could determine which one they were. 500 of them went out in envelopes that were from the Democratic Party of Wisconsin. The other 500 went out in envelopes that were from the Republican Party of Wisconsin. Now, I only got back about 90 to 100 from each group out of the 500. But guess what? The ones that went out in the envelopes from the Democratic Party of Wisconsin had much more liberal results. The ones that went out in the envelope from the Republican Party of Wisconsin had much more conservative results. Because if you get a letter from the Republican Party of Wisconsin and you're a liberal or Democratic person, what are you going to do with it? You're going to toss it. Yeah, you're not going to open it. You don't care what it says. So, I mean, little things like that can determine your results. So what do we want? We want what's called a random sample. And there's actually something even more powerful than a random sample called a simple random sample. In a random sample, I'm not going to say each person because it might be items that we're testing or whatever. Each item in the population has the same chance. So in other words, each person, if I'm doing the average age of students at WITC, every student at WITC has the same chance, same probability of being selected to be surveyed. That would be a random sample. A simple random sample, let's say I decide I'm going to survey, well, we said 20 people, right? We use the letter small n to represent the size of a sample. So if I said 20 people, well, an n would be 20. A simple random sample, every sample of size n, has the same chance. You might be looking at that figuring, how is that different? How on earth is this different from that? Well, a simple random sample, the best way to describe a simple random sample, and pretty much the only way to, I mean, there's other ways to mechanically do it, but the only real conceptual way of doing it is if I took the names or ID numbers or whatever of every student at WITC, threw them into a hat, and drew out 20 of them. In that case, not only does every student at WITC have the same chance of being selected, but every group of 20 students has the same chance of being in that sample. A random sample, one way of doing it would be I could take all the students from WITC and put them in order from their student ID numbers. And let's say, okay, if there's 2,000 students, I'm going to select 20 of them. That means I have to select every 100th student, right? So what I'm going to do is I'm going to randomly select a student from 1 to 100. And let's say I select 47. So I'm going to take the 47th student. I'm going to take the 147th student, the 247th student. Am I going to get 200 students? Yes, I am. Does every student in the population have the same chance of getting selected? You bet, because I selected 1 through 100 randomly. But does every group of 20 students have the same chance? No, they
Are
don't.
there that many students here?
There's about 2,000 students between the 4 campuses.
And but
Rice Lake, I think, is like 500 or 600. Okay, that's a good place to take our break. So let's stop.